Hi everyone. So in this video, we are going to discuss the solutions of CS1 A for IAI March 2022 session. Before we start with the discussion, one important announcement which IAI recently made was that the next set of examinations will be held in the month of July. Certain students do have certain questions in mind, whether we would be having examinations in the September session, or when would the next session after July be? Is IA planning to conduct 3 sessions in a year or more than that, something of this form? So all of this will need to wait to get some formal communication from IA. The examination in the September term looks very unlikely, given that post July it will be just 2 months or less than that. So maybe the next set of examinations post July could be in the month of November, as speculated by many. But we should wait for further confirmation from II regarding that. As for the classes at Finatics, we would be starting with our batches for the September IFA 2022 session, or the session for II post July. For July, there is no separate online session, as it's not possible to properly complete each and everything of a paper in the remaining timeline. Online batches would be available. There would be one single batch, whether it's for II, IFA, one single combined batch. Classes would be held on a regular basis on weekdays as well as on weekends. As for offline classes, they would be beginning from Calcutta, at least for the September 2022 session, and for other cities, that is something we could be doing post that, post September 2022. All the students, whether taking offline classes or online classes, would be having access to all pre-recorded content as well, so you would have the flexibility to self-pace your course. So given that we just have a single batch, and we do have a limited capacity for online and offline classes, so any one of you who is looking to join us, please do so at the earliest. It will ensure that you get maximum possible time from us, as well as it will ensure that you yourselves have sufficient time to cover the syllabus for. Starting with this, the first comment regarding CS1 paper, I would say it was a good paper. Certain questions were pretty straightforward. Certain questions was, I would say, slightly challenging. Would have forced students to think a bit more regarding how to go about this. But overall, keeping in mind that the pass marks as of now is 50, it's very easy to score 50, and the well prepared candidates should have been able to attempt close to 90 to 100 marks of the paper within 3.5 hours itself. So the first question is, assume for a health insurance policy the number of claims follows a Poisson process with a rate of 0.3 per year. So if I define n to be the number of claims in 1 year, therefore n follows Poisson 0.3. First part is we need the probability that there are no claims in the first year. This is equivalent to saying that probability n is equal to 0. This comes out to be 0.740818, so on. Just keep this in mind going forward in case you come up with any solutions which is not matching with what I have, or if you observe any calculation mistakes, please do let us know through the comments section so that we can rectify that and inform our other viewers of this video as well. Second part is basically asking that in the next 4 years, one or more claims in two of the years and no claim in the remaining 2 years. Okay, so 4 years are there. Okay, 2 years we would be having no claims, and in the other 2 years we would be having one or more than one claims. So the total ways, there are multiple ways. Either you could model it in the form of binomial, wherein my parameters would be 4 comma, and let's say my p is probability of 0 claim. So I'm here looking for, let's say, probability n equal to 2. That is, in exactly 2 years I want 0 claims. Alternatively, we could do it logically as well, the way I have done it. In 2 years I need 0 claims, in the rest 2 years I need more than 0 claims. So the total ways to arrange this is 4C2, probability n equal to 0, I square it, because in 2 years we need 0 claims each, and n greater than equal to 1. In the remaining 2 years I want the number of claims to be 1 or more than 1 whole square. Remember that probability n greater than equal to 1 is nothing but 1 minus probability n equal to 0. And in solving, we'll get this to be 0.2211991712. Next is the probability that, given that we have received a claim right now, what's the probability that the next claim would be after 3 years only? So it's equivalent to saying that no claims comes in the next 3-year period. Alternatively, if t is the time to the next claim, I know that t follows exponential 0.3 distribution. So this will be e to the power minus 3 into 0.3, which will come out to be 0.40657. Now you could see the one silly mistake which I made was probability t greater than 3. I wrote the formula as 1 minus e to the power. Now that is the formula applicable for a less than type probability. Then later I realized that no, directly it's greater than. So that is why you see a crossover here. So you see such kind of errors are very common. So that is why if you're able to complete the paper beforehand, you can spend some time going step by step. And when you go through it, don't just assume that whatever you have done is correct. The way I go at is I try to think, no, I have done something wrong. Now let's try and find something wrong. Because a lot of times in your mind, you know that this is correct, what else could be wrong, and you miss on these things. So this is something which I would say from my personal experience is very important in examination. And I would say more important specifically when you're working in a corporate setup, wherein you're working with large data sets, you're constantly working in Excel or maybe any other platform, and you tend to make certain errors. So if you try to check it thinking you have done everything correctly, you'll tend to miss out on these. But if your focus remains on trying to find where you could go wrong, in that case identification of error becomes a lot more easier. Otherwise subconsciously you think, this is right, this is right, you just skip on, and in this case you might be not able to identify a particular error. Part 4 is basically how the steps to perform a simulation. That is straightforward direct bookwork. We have a discrete distribution. In this case it's a Poisson distribution, and we know the approach for that. Part 5, I find probability n equal to 0, n equal to 1. I find the CDF F0, F1. Now F0 is 0.740818, and I see that the first number is 0.7521, right? So F1 is 0.963063. So this number lies between F0 and F1. So my simulated value is 1. As for the second one, my simulated value is the uniform random number is 0.6512. So this basically corresponds to a simulated value of 0, because my F0 is only 0.740818. Next question, question 2, I need to calculate S1 square, S2 square. This is using the standard formula. I get it to be 6.385, 22.814. Part 2 is testing, whether mu is equal to 18 or not. It's a two-tailed test because you can clearly see it's mu not equal to 18. Putting in all the values, the test statistic will be of T14. The critical value will be 2.624. Remember, it's a 98% confidence two-sided interval. So the critical value you need to look at it is 1%. Either it could be negative or positive. Here, since I've got a positive test statistic, I should be looking at the 99th percentile. Or however the way you want to interpret, I basically need to look at the positive value. That is the value greater than which the probability would be 1%. So you could say it could be 1 percentage point as well, which is 2.624. So we have sufficient evidence to reject H naught at 2% significance or 98% confidence interval. So this we need to perform the test for sample 1 only. Part B, we need to find the confidence interval for sample 2. Again, you'll see while working through this, I made a silly error. Instead of writing X bar, I first wrote mu and then it did it as 18, but it should actually be X bar only. So putting up all these things, I'm getting it as 16.56 and 23.03. Note that 18 does lie in this interval. Therefore, we have insufficient evidence to reject H naught over here. Next is discuss the reasons for differences and similarities while comparing the results of sample 1 and sample 2. So we see that both the samples have same mean, but their sample variances are different, and this is going to result in different confidence interval coming or even different conclusions for test as well. Part D is a new 100 size sample 3 is collected from same population. Explain how the width of the confidence interval of sample 3 will differ from confidence interval of sample 2. So first of all, remember that higher is your sample size, lower should be the width, keeping all other factors constant. But here that is not the case, because the new sample 3 which you would be drawing will have a different sample variance. So now keeping all other factors constant, higher is the sample variance, so your wider would be the confidence interval. So whether ultimately the width of the confidence interval of sample 3 would be less, more, or same as sample 2, we cannot dictate. It will depend on the variance. If we say that the variance of sample 3 is, let's say, same or less than sample 2, in that case definitely the width in sample 3 for the confidence interval would be lower. But in case the sample variance of sample 3 is higher than that of 2, in that case any possibility could be there, the width could be same, more or less, depending on the magnitude of the sample variance of sample 3. In part E, we observe that one single claim in sample 2 had extremely large value, and this can be considered as an outlier. And then we selected a randomly new one, which is not an outlier anymore. So how this is going to affect is, first of all, we are replacing a large value by a relatively low value, so the sample mean will decrease. So this will shift the confidence interval towards the left side. Not talking about width, just a shift towards the left. Next thing, we're replacing a higher value with a lower value, a very high extreme value with a, let's say, lower value. Therefore, my sample variance will also decrease. The effect of this is that my confidence interval will become less wide. It will become narrower in nature. So what I can conclude is that my confidence interval would have shifted towards the left, and it would have been narrower as compared to earlier. So the width would have decreased. Question 3, x follows gamma 5, 1 by 8, y follows gamma 3, 1 by 4. We need to find the MGF of x. So it's direct. If you will remember the formula, it's MGF of a gamma distribution is 1 minus t by lambda whole to the power minus alpha. And so here we would be getting as 1 minus 80 to the power minus 5, which is option C over here. That's we get. In part 2, we need to show that x by 4 follows chi-square 10. So one way, and it's written use MGF. So, ideally, even if it was not used MGF, I would say using MGF remains the most efficient way. So I define A as x by 4, then my MAT is expectation e to the power TA. I replace A by x by 4. So this is nothing but mx t by 4, which comes out to be 1 minus 2t to the power minus 5. Remember that the MGF of a chi-square distribution with v degrees of freedom is nothing but 1 minus 2t to the power minus v by 2. So here v becomes basically 5 we have. So that is 10 by 2. My v becomes 10. So this corresponds to MGF of chi-square 10 over here. Next part is calculate the probability that the claim amount exceeds 40,000. Remember that here the claim amounts x and y are units of 1,000. So this would actually be 40 only, because we're already working in units of 1,000. This should have come while reading the question. Even if not, if you would have written x greater than 40,000 and tried to solve it, you would have seen that the answer is coming out to be 0, because it's probability chi-square greater than a very, very large value. So this is where, if you would have read the question again and you would have seen the units, you would have realized that the expression which you're looking for is probability x greater than 40. You will see I started with 40,000, then I realized something looks off, and then straight away I saw units of 1,000. So it's probability x greater than 40. I divide by 4, so x by 4 is nothing but chi-square 10, and this can be directly found out from the tables. Now again, what I did was, earlier I looked at the wrong value, probably somewhere below that or left of that, and then I realized I'm looking at the wrong value while recorrecting it. So the answer is coming out to be 0.4405. In the last part, I need to show that x plus y does not follow the given distribution. So one way of that is to find the MGF of x plus y. So MGF of x plus y, I have skipped a step over here. It's independent, so it will be the multiplication of individual moment generating functions. So it comes out to be 1 minus 80 to the power minus 5 into 1 minus 40 to the power minus 3. Clearly, this is not equivalent to 1 minus 80 by 3 whole to the power minus 8. Therefore, x plus y does not follow gamma 8, 3 by 8. You cannot, if you add two independent gammas having different alphas and lambda, it does not result into a gamma with both the parameters being added up. That is not the case. Part 4, it's of an EBCT question. I will show you the workings for part 1. Part 2 and part 3 are typical questions which have been tested in past year, specifically from let's say IFO as well. So if you have access to revision notes, you would have seen that, wherein if certain values are increasing by a particular rate, then the way to adjust this is using EBCT model 2, and you divide each year's data accordingly. So I'm not getting into part 2 and 3 in detail. As for part 1 calculation, first I find the overall sample mean. So I have the summations part, I add all of them up, I divide by 12, and I get this to be 4296.33. Then I find expectation S square theta, which rounded off to the nearest integer, I'm getting this to be 41158. Then I have variance M theta, again the formula which is directly there in the actual tables. Feel free to use that. I mean, you should be using that. And to the nearest integer, I'm getting this to be 30,640, and then I find the value of Z, which comes out to be 0.95534, so on. So my credibility premium here will be Z into 4484.33. Note that this 4484.33 is nothing but the mean of the sample which I'm interested is the policy number 4 over here. So 13,453 by 3. This is my mean of policy number 4. This I multiply with Z plus 1 minus Z into 4296.33, which is the overall mean of the entire sample, combining all policies together. Next question, I would say very straightforward. We need to find the value of K. Part 2 is, finding the right marginal density and so on. So we'll take a look at each of these. It's a standard double integration involved, there's no relation between X and Y, as in there's no single term which has both X and Y together. We can easily split out, perform integration as usual, and we'll see that K comes out to be 3 by 5 or 0.6. We need to find marginal distribution of X. We have this formula direct, multiplied, and it comes out to be 3 to the power minus 3x. And here I've identified that here X follows nothing but exponential 3. And similarly, Fy will be 1 by 5 e to the power minus y by 5. And so basically y follows nothing but exponential 1 by 5. So my correct option here in this case would be C. This is the MGF of Fx, and sorry, not option C. It should be actually option B over here. 3 e to the power minus 3x, 1 by 5 e to the power minus y by 5. So, okay, I've written it B only. I misread this as C. Option B is the correct one. Next is to check whether they are independent or not. In fact, they are, because the product of the marginal is equal to the joint probability function. So therefore, X and Y are independent. Next is to find the conditional PDF, Fx greater than X greater than 5. We directly have the formula of this. Fx is 3 to the power minus 3x. Probability X greater than 5. X follows exponential. I'll use that fact. So this becomes e to the power minus 3 into 5. And note that this term will only be valid when X is greater than 5. So this is my PDF, and don't forget to give the condition. There should be separate marks for this condition as well, because this is gonna come very handy later on as well. Even for completeness, you need to always mention the range, and when performing further stuff like integrating and all, this would be required. Next is finding the conditional expectation of X given that X is greater than 5. Not directly calculate, but we need to select the most appropriate option. So this is the formula. What we are going to do is going to apply integration by substitution. I substitute X minus 5 as T, and then I go on, and then basically I can reduce it to this form. And this is nothing but what we have in option D, if I'm not wrong. Yeah. This is option D over here. So again, I would say a fairly direct question. Should have been scoring one, specifically few parts of it. Question 6, for a normal model, we have the formula of Z. So if n as sigma square increases, this denominator term increases, so this particular term decreases. Therefore, this entire denominator keeps on decreasing, so Z will keep on increase. Note that it's of 4 marks if I'm not wrong. 6, it's of 5 marks over here. You need to give the logical explanation as well. So the explanation of this is what is sigma square, right? If sigma square is increasing, this is the basically variance in between the data. So when variance in between the data is increasing, we can give less let's say credibility to the external data. which implies that we give more credibility to our data, which results in a higher value of Z. S square is nothing but the variance observed in my own data if the value of that increases. It means my own data is more variable, therefore it will be less credible. And therefore, if it's less credible, then the value of Z should be lower. And Z is independent of mu naught. As we see, there is no mu naught term in Z itself. So remember that I have written it in a very concise way. This will not fetch 5 marks. You need to give the explanation in words as well. As you know, why we also expect that. Mathematically, we are clearly seeing this, but logically also it's better if you could explain that why this happens. Next question 7 is there. We have a region X, we have a region Y, and we have certain other information. First part is X bar is greater than Y bar. So here I would say a lot of students, when I was talking to post-examination, when computing these probabilities, they tried to interpolate, they come up with an answer which was not matching and they selected option E, which I guess is fine because we generally, when we're trying to find probabilities from a standard normal distribution, we could generally go till 4 decimal places. Till 2 decimal places, we could round off and directly get from actuarial tables. But obviously, we could go till, let's say, 3 decimal places or 4 decimal places as well, and then find a more accurate answer. And if somebody uses more than that, in that case, a more accurate answer will come, but it might not be in these options. So they were getting none of the above. Now, this is something for IA to decide whether they would be marking these students or not. Again, if somebody just does option E, then I mean, it's difficult whether they give marks or not. But if, let's say, somebody has shown the working, which is not actually required for MCQs, in that case, the examiner might say, this student has tried to be even more accurate, not rounding up to 2 decimal places. And if then they have selected option E, they could have been awarded for. Here, if I rounded out to 2 decimal places, which we will shortly see, then the answer comes out to be option C over here. So it's getting, Z greater than 2.581988, so on. Not depending, somebody could have rounded off till 2.582, even till 4 decimal places, it's 2.5820. The answers you would have got would have not matched to what is there. So you could have selected none of the above. But if you're rounding off to till 2 decimal places, you are getting 0.00494, which is there already in the solution. Next part is we need to find that the sample variance S square X is greater than 100. So again, it's a very straightforward question, and the answer is 0.4373, which I'm getting. Next part is calculate the approximate probability that sample variance of X is less than the sample variance of Y. So while working, I somehow did, I somehow assumed myself. See, the question is asking that the sample variance of X is greater than that of Y. So initially I started with everything greater. Then I realized ki again just going through the workings again, which I tend to do, something which you all also should do. Takes time, but then remove such silly mistakes. S square X is less than S square Y. Went about with the usual approach. Was getting something like F9, 4 is less than 1 by 4. Now in our actual tables, we do not have a value of anything less than 1. So we would need to convert this F probability, whether greater than or less than on whatever is the number, this should be greater than 1. So I take reciprocal of this and we use the fact that 1 by F A comma B is nothing but F B comma A. And by interpolation, this is coming out to be roughly 4.2%. Part 4, again, it is getting Sx is greater than 4S4. Okay, so in part 3, we already have an option B, it's 4.2%. So we select that. Now again, depending on some or the other interpolation, you could get none of the above. So it's on the discretion of IAI, how they go about intend to mark this. Part 4, its probability Sx is greater than 4 S4, so on. And the answer which I'm getting is 0.985. Moving forward to the next question. Question 8, part 1, define conjugate prior distribution. It's direct theory bookwork. Part 2 is x1, x2 comes from exponential distribution. Lambda itself is gamma. We need to find posterior, or sorry, it's here show that prove that the conjugate prior is lambda. So basically, you start with prior as a gamma distribution and then find the posterior, and you'll see that the posterior is also gamma only. Part 3 is lambda is gamma alpha comma beta. Deduce that expectation n by lambda is this. So let's take a look at part 3a. Expectation n by lambda is integral n by lambda into the PDF of lambda, where lambda follows nothing but gamma, alpha, comma, beta. Remember that there is no x over here. My random variable here instead of x is lambda. So just keep this in mind. Otherwise, you will remember e to the power minus lambda x. There, lambda was a parameter in gamma distribution. Here, lambda is a random variable which has a gamma distribution with parameters alpha and beta. This is a very, very common mistake which a lot of students tend to do in this topic. So I take out everything constant outside, then I have lambda to the power, let's say alpha minus 2. So this is nothing but basically gamma integral. The result of this is gamma a minus 1 divided by beta to the power a minus 1. And if I just rearrange it together, I have shown another step for completeness. I mean, this reduces to n beta by alpha minus 1 only. Next part B again, which I didn't show, but the posterior distribution would have been gamma a plus n comma summation xi plus beta. So the posterior expectation of n by lambda, using result from here, the earlier part where we were getting n beta by a minus 1. So here this shall be n summation xi plus beta, which is the second parameter, divided by first parameter minus 1. Now I try to regroup this in the form they are asking us to do, and we are able to show that z into summation xi plus 1 minus z into expectation of this n by lambda. Note that this is the prior expectation. Moving forward to the last question, which was pretty lengthy, 30 marks, a lot of parts over here. First part is Poisson distribution. We need to find the variance function. Remember that variance is different from variance function. Variance function is nothing but b double dash theta over here. So I have written here for completeness, this is the typical structure. If I compare to what we have been given in the question itself, then b of theta is nothing but log mu. And let's say, sorry, b theta is nothing but mu and theta is nothing but log mu. So basically b theta is nothing but e to the power theta. If I double differentiate this, remember that the differentiation of e to the power theta with respect to theta remains same. So this is nothing but finally mu over here. So variance function is nothing but mu. Next we need to find, the variance function is coming up. Next we need to find both b dash theta and the mean and the variance. In part B, basically b theta is given minus log minus theta, so on. So remember that mean is b dash theta, variance is b double dash theta into a phi. A phi is 1 only, therefore my variance is equal to variance function. So here basically we'll get mu and mu square, and this basically corresponds to option C. Next part is a student modeling accidental hospitalization claims found that interaction between age band and gender is significant. Explain what this means for the model predicting accidental hospitalization claims with reference to beta parameter for gender. So what they're saying is that the interaction term is significant. The moment there is an interaction term, the beta parameter varies depending on gender. We might have a beta for a male as well as for a female, assuming that we have two genders, male and female over here. So this is what it implies. First of all, the interaction term is significant. That is, the beta parameter for males and females shall be different. And then they have written, you are told that males are more prone to accidents than females, and hence males require more accidental hospitalization. So we could say that the beta of males, let's say, could be higher. Something like of this form. Point is, they are more because they are more prone to accidents. So this is the case over here, is how you need to go about it. We'll have a separate beta, that is the underlying important stuff. Part B, a student is fitting GLM model to predict policy renewal rate for a group of policies. Comment on the choice of link function that can be used with suitable expression. We need to find the policy renewal rate. So that is, if we define that to be the proportion of policies being renewed, it should ideally be between 0 to 1. So my natural link function for this will be the logit function, which is basically ln of mu by 1 minus mu. This becomes my eta. This will ensure that whatever be the value of eta, the value of my mu will always lie between 0 to 1. That is the underlying essence over here. And we generally start with a binomial distribution. In this case, let's say if you have n policies, then how many policies can be renewed? It could be 0, 1, 2, so on till n only. Next, we have part 3. Identify A, B, C. It's a typical standard ANOVA table which has been given. So I'm just quickly going through the solutions. A will be 1.38 by 1 for model 1. For model 2, it shall be 2.38 by 1. B becomes the total minus A, 5.38 minus 1.38. C again becomes nothing but the value of B divided by degrees of freedom, 4 by 12, 0.33. Similarly, for model 2, B is 3, C is 0.25. F for model 1 is coming out to be 4.14, and for model 2 it's coming to be 9.52. This is a 2 over here. At 5% significance, it's not mentioned, is it so? Clearly it's not mentioned at what significance. You could do it at 5%, 1%, 10%, up to you. Generally, as standard, I do it at 5% significance or 95% confidence interval. We will see that for model 1 we do not have sufficient evidence to reject H naught, but for model 2 we do have sufficient evidence to reject H naught. And then comment part 3 is, comment on the suitability for model 1 and 2 using R square. So we know the formula for R square. This is nothing but SS regression by SS total. For model 1 it's 0.25. So very low proportion of variability is being explained by the model. For model 2, a higher variability is being explained, but you will see that in model 2 we were rejecting the linear relationship, but whatever variability was there, that was being a higher part of it was being explained by the model. And finally, part 4, we clearly see here the p-value is very small. Okay, so we have sufficient evidence to conclude that model 2 is significantly than model 1. Similarly, for result 2, p-value is very less, again less than, if you conduct at 5%, this is 0.4%. So we do have that sufficient evidence to conclude that X asterisk region is a better model compared to this. But when I take a look at model 3, X plus region, X asterisk region, what I see is p-value is 0.9245. Therefore, I do not have sufficient evidence to reject H naught. Therefore, I cannot say that this model 2 is significantly better than model 1. Remember that it would be wrong if you say that model 1 is significantly better than model 2. Model 2 is definitely better. You see, we have a lower residual variance. It is definitely better, but not statistically significantly better than model 1. So we reject the H naught, and therefore we stick to model 1 as the appropriate model only. So hope you all found this video very helpful. In case of any calculation errors or any other error you feel there is, please do mention it in the comments so that we can take a look at it and rectify if required. Don't forget to subscribe to our channel so that you all are notified regarding all the new contents which we keep on releasing. So that's it from my end. Hope you all found this video useful. Bye.